When we see a modern airliner, it's hard to believe that airplanes used to be clumsy, noisy, rather primitive machines.
My first experience in aviation was a Piper Cub, a very small airplane, a small engine. We didn't even have an electrical system, and to find myself in this airplane, it's a tremendous contrast. I mean, it's like finding yourself on the moon.
A computer has really advanced the art of flying beyond the capability of pilots in terms of the very sophisticated end of it.
Less than a century ago, few people would have dared to imagine what we now all take for granted. The safety, speed, and comfort of modern airliners has changed humanity and brought the world closer together. Despite increasing demand for air travel, building a new airliner is a gamble. Even with a close cooperation between the airlines and the airplane manufacturers, the undertaking remains risky and expensive.
We need an airplane that is fuel efficient, can fly a long range, do that job well, but still be compatible with the airport.
But they can only produce airplanes that match the available engine technology. They can, engine technology always dictates the airframe size and the performance of an airplane. So the two have gone hand in hand. And as the markets have developed and airlines have tried for particular airplanes to handle particular markets, the engine manufacturers and the aircraft manufacturers try to meet it.
When Boeing began construction of what would become the world's largest twin-engine commercial airliner, the company's past legacies were drawn upon in every possible way. Boeing hopes the 777 will be the jet for the next century, that it will be an airplane customers ask for by name.
The primary reason that I really enjoy flying the airplane is that it's just right up there with everything. So it is taking advantage of some technology that's been around but hasn't been really applied to commercial aviation in the airliners. So to me it was exciting. It was something new, something that was in the forefront of commercial aviation. So it was just exciting to be a part of it.
Few things have changed the face of the world with the force of the computer and the jet airplane. And now, as we stand at the dawn of a new century, these two elements have come together to push us into a new age of international travel. And this new era begins with an airplane designed for the next century, the 777. We live in an age of travel. People of all nationalities from all corners of the earth yearn to explore, to visit new places, to meet new people and reunite with old friends. The dramatic rise in demand for jet travel has prompted airplane manufacturers to look closely at which routes are most traveled and how best to serve the changing marketplace of air travel.
Air transportation has grown at such a tremendous rate. There's so many more people flying and so many more airlines flying. I mean, airlines have so many more routes now, even though they've sort of consolidated them into the hub system. There's still many, many individual airline routes that they actually need airplanes tailored to specific markets. They wanted something that was a little larger, a little longer range than the 767, but not so expensive to fly as the 747.
The development of commercial airplanes has always been driven by market forces. In the late 60s, the Boeing company began to work closely with their customers to respond to changing demand. With a belief in their vision of commercial aviation's future, they gambled the worth of the company, and the result was legendary. Introduced in 1969, the 747 revolutionized the world, bringing long-distance jet travel within the reach of the common man. The 747 has enjoyed a remarkable legacy of success, and its name has become synonymous with international travel.
Well, the 747 is just almost like the cathedrals of past structure in terms of its size and its impressiveness. From a pilot standpoint, you sit in a cockpit and you look out and you can scarcely believe you could land the thing.
We talk of it in cents per seat mile, but it's inexpensive enough now to make it open for everyone. Everyone can fly. What started out as our greatest risk turned out to be our greatest reward. It exceeded our fondest expectations.
The gamble that produced the Boeing 747 created a revolution in commercial air travel, from which there has been no turning back. The energy and resources which drove the development of the 747 30 years ago is now embodied in the latest Boeing success, the 777. With a length of 211 feet and a wingspan of 200 feet, it is the largest twin-engine commercial jet in the world. Designed to carry more than 300 people distances of up to 5,000 miles, the 777 is a remarkable tribute to the evolution of aeronautical technology. Made up of millions of parts, the 777 is a world away from the fragile wooden airplanes originally built by company founder William Boeing. Boeing's company got its start in the First World War, and after the United States became involved overseas, Boeing was awarded a Navy contract to build 50 aircraft. After the war, Boeing looked beyond the world of military airplanes. In 1919, he decided to show North Americans that his planes could perform civilian tasks, like carrying mail. Carrying people was next. This Model 80A could carry 12 passengers and boasted the industry's first air stewardess. Although this plane was successful, it could hardly match Boeing's next creation, Model 247. Model 247 is perhaps the original prototype for the modern airliner. It could carry 10 passengers and could fly 189 miles per hour. Model 247 could, with 7 stops, complete the trip between New York and Los Angeles in 20 hours, 7.5 hours faster than the best previous time for an airliner.
It revolutionized the world with the Boeing 247, which was an all-metal, low-wing monoplane, cantilever wing, retractable landing gear. It was absolutely sensational, faster than anything in the field. They thought that they would sort of corner the market. They would sell them all to United Airlines, which was part of the Boeing company at the time. And they made the mistake of saying, okay, the first 60 go to United, and then we'll begin taking orders. Well, other companies rebelled against that, and TWA went to Douglas and placed an order for an airplane that was essentially, the prescription was better than the 247, and Douglas achieved that with the DC-1, DC-2, and DC-3.
The Douglas DC-3, a low-wing, twin-engine monoplane, first flew in 1935 and emerged as one of the first airplanes profitable for the airlines. The DC-3 could carry 21 passengers nearly 1,500 miles at speeds of nearly 200 miles per hour. Faced with serious competition, Boeing turned its attention to size with the 4-engined XB-15. This was the first really big plane to use state-of-the-art technology and high-performance power plants. Only one XB-15 was built, but Boeing had established itself as a manufacturer of big aircraft. When Juan Trippe of Pan American Airlines approached Boeing to build a big flying boat to fly the intercontinental passenger routes, the engines and wing design of the XB-15 were molded to fit the new hull, and the Model 314 Clipper was born. 106 feet long, with a payload of more than 15 tons of fuel, passengers, and cargo, the Model 314 was an enormous plane. Capable of flying 3,500 miles, the Clipper brought the dream of international travel a bit closer to reality. With a range and capacity to carry 2 shifts of flight crew, it made regular scheduled transatlantic services possible. At the same time, Boeing was moving in another direction, upward. It had designed and built Project 299, the prototype for the B-17 Flying Fortress, using the idea of 4 engines and a smaller fuselage than the XB-15 in order to improve performance. The B-17's wings and tail assembly were given a pressurized cigar-shaped fuselage to produce the 4-engine Stratoliner. A supercharger provided oxygen for high-altitude engine performance and fed pressurized air to the cabin. It was the first pressurized airliner to enter service, and the airlines ordered 10 Stratoliners. The plane first flew on December 31st, 1938, and created great excitement with its ability to fly at 26,000 feet and carry 33 passengers. But a plane that seemed destined for greatness ran into trouble. A bad crash of Stratoliner number 1 led to the addition of a dorsal fin to improve stability, and the airlines were a bit wary of the new plane. Despite the prospects for the Stratoliner, by 1939, nearly 90% of worldwide passenger traffic was handled by DC-3s. As Boeing and Douglas battled in the commercial world, events in Europe changed their focus from planes of peace to planes of war. The Second World War unleashed a both terrifying and wondrous growth in technology. Under the pressures of war, the world of aviation would change forever. Few outside of Germany realized just how far German engineers had pushed the envelope of aviation technology. Merely a week before their invasion of Poland, Germany gave the world the first glimpse of aviation's future. Ernst Haenkel's HE-178, the world's first jet, made its initial flight in late August of 1939. Two years later, the Germans tested another jet, the HE-280, an exceptional aircraft which would have seen active service had political disfavor not fallen upon Ernst Haenkel. The Germans were not the only ones to see that the jet was the future. In Britain, Frank Whittle had been experimenting with jet engines for several years. Although Britain did manage to get a few jets into service, the Germans were the undisputed leaders and proved it with their legendary Messerschmitt Me-262. The Me-262 demonstrated the efficiency of merging jet engines with swept wings, a combination which would ultimately bring us the 777. The dawn of the Cold War came immediately upon the heels of Allied victory. And while airplane manufacturers looked back to the commercial world, the military needs could not be ignored. The formation of the Strategic Air Command in 1946 represented the American commitment to a strategy of retaliatory long-range strategic bombardment. Throughout the war, the Boeing Company had supplied the American forces with some of the most famous bombers of all time, the B-17 and B-29. This success made them a natural choice to develop a new bomber.
They had begun to see that in the post-war world, they needed a jet bomber. And the jet bomber took advantage of the newly available German technology and American technology which had surfaced by the end of the war, which involved swept wings and jet engines. Their first attempt in this area was a magnificent success. For a $13 million contract, they produced the XB-47. And this was a 6-jet swept-wing bomber, absolutely revolutionary. It was fast, it had long range because it had in-flight refueling capability, and nobody else in the world had anything like it. It was a decade ahead of any other country. Well, Boeing looked at that and said, well, how can we convert it to a commercial airliner.
Boeing had not been totally absent from the commercial world. Between 1947 and 1952, they had built 50 Model 377 Stratocruisers. The Stratocruiser was the ultimate in luxury travel, in an era in which only the very wealthy could afford to fly. Its most famous feature was the spiral staircase, which connected the cabin with a lower deck lounge, where passengers could stretch their legs and enjoy a change of scenery. There was also a ladies' lounge, a convenient facility for keeping up in flight appearances. Boeing's main competitors at the time, like this Lockheed Constellation, were essentially pre-war designs. Other planes, like this British Hermes, were adequate for the transoceanic routes. But air travel had not boomed like many had thought. The high cost prevented most people from flying. In 1952, the British Comet seemed poised to lead the way to an era of jet travel. But two crashes grounded the Comet fleet and left airlines and passengers wary of the jet. But the success of the B-47 had convinced Boeing that large jets could be safe and efficient. Their expertise prompted them to build an even bigger and more powerful jet bomber, the B-52. With both the B-47 and B-52, the standard bearers for the post-war bomber, Boeing gambled that they could use this new technology to change the world of commercial aviation.
This was a tremendous gamble. The airlines were well served at the time with Douglas DC-7s, Lockheed Constellations, and the jet was going to be expensive, going to be terribly risky.
Under a veil of secrecy, Boeing invested $16 million of its own money into a stunning new airplane, the Dash 80. This legendary airplane served as a dual prototype for a military tanker and commercial jet transport, introduced as the Boeing 707. With a familiar combination of jet engines and swept wings, the design of the 707 remains the basic standard for virtually all commercial jets. From its introduction in October of 1958, the 707 sparked a revolution in jet travel, which has dramatically changed the world. Although international travel was still expensive, the 707 had brought this dream one step closer to the common man. The comfort and speed of commercial jets made flying a much more pleasant experience, and Boeing knew that there would be a need for much larger jets to accommodate growing demand. But in the early 60s, much of the company's energy was focused on a military contract to build the massive jet transport, the C-5A. In August of 1965, they lost the contract to rival Lockheed, an event which would bring the world the first jumbo jet.
If we had won that contract, it would have absorbed a great deal of our energy, and we probably would not have gone forward with the 747 at that time. It would have been later. However, the fact that we lost it, and that released a fair amount of energy and resources to do something else, we were anxious to get moving, and it, in a sense, probably accelerated our going into the 747.
Boeing's big gamble began in the forested hills of Everett, Washington, 30 miles north of Seattle. Boeing didn't have a factory large enough in which to build the jumbo jet, so an army of workers set about constructing one. Undeterred by the relentless Washington rain, Boeing engineers began construction of the first 747 before the roof of the $200 million factory was completed. With the future of the company at stake, all the company energy and resources were thrown at the massive project.
They were very, very motivated. The workforce, there was no need to try to energize them. They were on a very romantic task. They're building the world's largest airplane. They had an enthusiasm that welled up, and finally someone coined the word that they were the Incredibles. And they really did a yeoman's job. Yeah.
On September 30th, 1968, it was time to celebrate.
26 months ago, as we stood amidst the forest up here at Everett, and the decision was made to go forward with the 747 program, the magnitude of the task that we were faced with really looked formidable.
"26 stewardesses, representing the 26 airlines that have ordered 158 747s, take part in the christening ceremony."
If you haven't got a bottle, raise your hand.
Since the plane's first commercial flight in 1970, Boeing 747s have carried more than 1 billion people to all corners of the Earth. The success of the 747 prompted Boeing to develop several other versions of the airplane, including a short range, a special performance model, and an all-freight model. The 747 has also been used to carry the space shuttle. And in perhaps its most prestigious role, the 747 serves as the presidential aircraft, Air Force One. The 747-400, Boeing's long-range version of the jumbo jet, was introduced in February of 1989. Bigger, stronger, and faster than previous models, the 747-400 still looks nearly identical to the original. Digital avionics have replaced the old analog systems, and the new 747 reflects 20 years of technological progress. Capable of carrying 420 passengers more than 8,000 miles, the 400 will continue the 747's proud legacy well into the next century.
The jet aircraft as a whole has revolutionized the world. I mean, it's democratized the world. It's a very egalitarian kind of thing now. When you get it into a Heathrow, for example, you see 50 different nationalities. You don't even know the countries. You can't even identify the people where they're from. You hear all the different languages, but everybody knows which booth to go to, and when they get on the airplane, they know how to get their drinks and so on. So it's a very egalitarian system. The 747 has accelerated this because it's able to fly so far.
While the 747 remains the most familiar commercial airplane, the cost of operating a 400-seat aircraft can be quite high, and the airlines have recognized that the jumbo jet is not always the best option. So airplane manufacturers have developed other airplanes to fly routes for which the 747 was too big. One of these airplanes, the Boeing 767, was introduced in the early 80s. This twin-engine jet typically carries about 200 passengers, serving medium-range routes of about 2,500 to 3,000 miles. In the late 80s, there emerged a need for a plane about the size of the 767, but with longer range. The 767's two engines were not powerful enough to handle longer trips, and the airlines expressed their desire for a brand new airplane to fill this niche. Under pressure from competitors and from the airlines, Boeing gambled once again and beat the odds.
We carry about 300 people on the airplane, and we fly at decimal 84 Mach, which is 84% the speed of sound. We normally cruise at around 37,000 feet, plus or minus, depending on the winds and the weight. But that's probably a typical flight for this aircraft.
The development and construction of the 777 was a tremendous task. Never before had computer technology been so closely intertwined with the production of a modern airliner. Boeing distributed 2,200 computer terminals to 238 design teams, all of whom were linked together through 8 massive mainframe computers. Engineers from the United Kingdom, Japan, and Canada could access the latest modifications as easily as an engineer in Boeing's Seattle home. By using the latest technology, design engineers and manufacturing engineers were able to work concurrently on the design of the plane.
They designed on computers this airplane and tested it on computers, so that when they built the first one, it wasn't a prototype and it wasn't an experimental model, it was a production model. An astounding feat with a computer age as much as anything else. It used to be that you'd see banks of engineers with little slide rules and big masses of paper, and an engineering drawing had to go through 100 channels and had to be carefully tracked and so on. All that's gone. You walk into a factory nowadays, you won't find a slide rule, or probably won't find somebody that knows how to use one.
From the beginning of the project in 1990, Boeing worked closely with its customers to meet their demands. Computer graphics allowed the airlines to visualize the integration of the plane into their commercial fleets. The digital pre-assembly of the plane allowed Boeing and its customers to recognize and correct problems while the design was still in development. 4 customers, United, All Nippon Airways, British Airways, and Japan Airlines, actually had on-site representatives working with Boeing to ensure the airplane would also fit their needs and fit into the airports. The 200-foot wingspan of the 777 posed a possible problem for the airports, so Boeing introduced a mechanism that enabled 22 feet of each wingtip to fold upward and thus fit into existing gates. One of the primary concerns for the 777 design team was the airplane's 2 massive engines, which would each need to produce 80,000 pounds of thrust. Many airlines have a special arrangement with engine manufacturers, so Boeing had to rely upon 3 different companies to develop the engines. Jet engine technology has been a primary factor in the success of commercial aviation. The remarkable durability of the modern jet engine is one of the first things that influenced the decision to make the 777 the world's largest twin-engine commercial aircraft.
The second thing that had to happen after the development of engines which would run almost indefinitely without failure was sufficient thrust, and this was simply a matter of time. Each generation of engines got bigger and bigger, each one found more ways to produce more thrust, and so you finally had Rolls-Royce, General Electric, Pratt & Whitney all producing engines of sufficient thrust that you could fly a large airplane like the 777 over water with assurance, A, that neither engine would fail because they both ran so well, but in the event that you had an engine anomaly, the remaining single engine was more than adequate to get it safely to its destination.
The thrust of one of the engines is more than the entire thrust of a B-52 bomber, just one of the engines. And that bomber had 8 engines. So that technology allows Boeing to build this airplane as a twin-engine airplane.
Boeing was determined to integrate the latest technology into every aspect of the airplane. The wings of the 777 are the most aerodynamically efficient ever developed for subsonic commercial aviation. The improved design of the wings allows the airplane to climb more quickly and cruise at higher altitudes than competing airlines. But the biggest difference was not in the wing design, but in how they operate.
Another thing, of course, is the wing designs. The composite materials make the airplane lighter and yet, maintain or even enhance the safety and strength of the components. Some of the other technology is the fly-by-wire.
Modern aircraft, for all practical purposes, are going to be, quote, fly-by-wire. Instead of having the old system in which you had pulleys and cables and rods to move from the control wheel to the aileron or the rudder or the elevator, you do it electronically. A computer operates it, and so the inputs the pilot makes don't go directly to the control surfaces at all. They go to a redundant computer system, and that makes the corrections.
You can actually send a control input from the control column through a wire and as an electrical input through a computer that analyzes it, enhances it, and makes any kind of corrections, and to the actual control surface itself. A good example is banking the airplane. Normally, in normal operations, you don't bank the aircraft over 30 degrees bank. The computer will let you go to 35 degrees, and if you try to exceed 35, it will actually give you a opposite input. You can feel the control wheel trying to tell you this is too much.
Although the mechanics of the airplane are obviously crucial to its safety and success, creature comforts were also very much a concern of the 777 design team.
I think it's very important that we do what I call aggressive listening, which means not only you listen to what the customer says, but what they mean. Ways of making the passenger more comfortable. We had one airline say, can you put a hole in the floor to put a bag into? We weren't able to do that, but we were able to solve the fundamental need, which was to give the passenger more room for carry-on bags with a bigger bin.
Well, this whole interior is in response to what the customers asked us for. The dimension of the airplane, 5 inches greater inside than a DC-10, really is in response to the customer's input. And they said, hey, we'd like to have, in business class, 7 seats across with the 747 seats. If you do that, then we can have you at the same seating comfort at 7 across as the Airbus is at 6 abreast. Some customers said they like a skosh more room in tourist class for the most comfortable 9 abreast ever in the industry, or an acceptable comfort 10 abreast in some market segments.
One of the features most talked about is the luggage bins, which are designed to open downward, a break from the traditional design on other airliners. Boeing's pride in the interior of the 777 has made the plane a popular choice for passengers.
Essentially, to a person, everyone has said this is the best airplane for the passenger and for the airline operator that they've ever seen from the interior standpoint.
Few people travel without baggage, and the 777 retains an impressive cargo capacity in its lower hold.
This airplane has tremendous cargo capabilities, not only in weight capability, but also in volume. Large packages can be shipped on this airplane just because of its size. But as far as the tonnage, we can carry as much cargo in the belly of this airplane than you can carry in a DC-8 freighter, the entire freighter. So it's quite a machine. Again, getting back to the productivity of it. It can carry a very large quantity of cargo, and that's a lucrative part of the business.
In the early spring of 1994, after nearly 4 years of intense design, development, and construction, the first 777 was nearly complete. Planning the ceremonial rollout of the first 777 was almost as difficult as building the airplane. More than 50,000 people had worked on the project, and with each person allowed to bring one guest to the ceremony, the total crowd would exceed 100,000. Therefore, on April 9, 1994, Boeing held 15 ceremonies, one on every hour from 6 in the morning till 8 at night. The plane stood still, but the crowds rushed forward for a closer look at this magnificent airplane. For 2 months after the rollout ceremony, Boeing engineers scrambled to ensure the airplane was ready for its first test flight. Loading and testing the more than 7 million lines of computer code had engineers frantically working around the clock. The airlines had already sold seats on the airplane for the following year, and thus the pressure to get the plane tested and ready was tremendous. Finally, on June 12, 1994, the big day arrived. It was time to finally see if 4 years of intricate design and development on computers would translate into success in the air. Orders for the airplane had to be met, and the tight deadlines were unforgiving. Any delays in the testing program would spell possible disaster for the company. The first liftoff and successful flight was a tremendous relief to the company, but the program was a long way from finished. For a year after the first test flight, 5 777s were used for a series of extensive in-flight tests. Delivery of the airplanes was less than a year away, and there was no room for delay. Each part of the plane had to be tested in a wide variety of environments and situations. The landing gear for the 777 is the largest ever incorporated into a commercial airplane and had to be rigorously tested. The main landing gear is a standard 2-post arrangement that features 6-wheel trucks instead of conventional 4-wheel units. With a total of 12 wheels, the weight distribution is easier on the runway, taxi areas, and on the airplane. The 777 was tested for emergency takeoff under strenuous conditions. Here, a 777 is tested for minimum speed takeoff, a metal support cushioning the damage to the airframe. The brakes of the 777 had to meet specified requirements so that the airplane can abort takeoffs at very short notice. Bringing more than 500,000 pounds of metal, fuel, and passengers to an abrupt stop is not an easy task. A 777 was throttled to takeoff speed and then stopped as quickly as possible. The heat from the brakes was significant, yet the airplane matched all expectations. One of the primary elements of the test program was ensuring that the engines were capable of meeting the Federal Aviation Administration's approval for extended-range twin-engine operations. This certification allows the airplane to fly routes which would take them 180 minutes from an adequate airport. The 777 has been developed with this in mind and was designed to land, take off, and fly for long distances on only one engine. On May 30th, 1995, the 777 became the first airplane to earn this FAA approval before it entered service with the airlines 8 days later. The 777 made its first commercial flight on one of the very routes which was the impetus for its creation, London to Washington, D.C. On June 7, 1995, a new era began. With wingtips neatly folded upwards, the first 777, complete with passengers, slowly rolled toward the gate, a sight which could not have been more pleasing for both Boeing and United. United and other airlines had sold tickets to customers eager to fly on the newest commercial airliner long before the plane was ready to fly. The tight deadlines of the project were a financial risk to all involved, and some skeptics predicted failure. The first delivery to United came 2 weeks before the plane earned the FAA's approval for extended twin-engine operations. There had been no room for error or delay, and remarkably, the deadlines were met. Once the plane finally entered commercial service, the sighs of relief went up from Boeing's Seattle home and resounded throughout the world of commercial aviation. As the passengers left the plane on this historic occasion, there were smiles all around. Boeing's dream of producing a plane for the next century, a plane which one day could be as identifiable as the 747, was one step closer to reality. The accolades from passengers and pilots has made the 777 the premier commercial airliner, the one people ask for by name. The end result of 4 years of intense work was a long way from the first computer images. The 777 represents a triumph of technology, a magnificent integration of two forces which have changed our world, the computer and the jet airplane. As Boeing now scrambles to meet the tremendous demand for the original 777 model, a newer one is under development. The 777-300 will be a higher capacity, stretched version of the original 777. Capable of carrying more than 500 passengers, distances of more than 6,000 miles. The newest 777 will fly routes like Tokyo to San Francisco, Honolulu to Seoul, and may well be the ultimate successor to the original jumbo jet. The first delivery of the 777-300 is scheduled for May 1998. In the meantime, the production lines at Boeing will sustain a furious pace to meet the demand for the original 777s with remarkable speed and efficiency. A perpetual reminder that this is a gamble which will continue to pay off for years to come.
The engines, the airframe, and the composites, and the avionics, fly-by-wire, all those new technologies have really come together in this airplane.
The 777 is the world's premier twin-engined airplane. With a wingspan of 200 feet, the 777 can carry 300 passengers up to 5,000 miles and can fly with a weight of 545,000 pounds. By using the full power of the modern computer, engineers have designed a remarkably safe and reliable airplane, with more creature comforts than some of us could imagine. Nearly 80% of the computers on board the airplane serve the needs of the passenger, from each individual digital sound system to the overall communication systems.
The jet aircraft and the computer were roughly analogous. The most primitive computers came at the end with World War II, and of course the jet aircraft did. But as airplane design progressed, computers design accelerated, and so that the computers became absolutely fundamental not only to the design of the airplane, but to the operation of the airplane. It would probably surprise people to know the numbers of computers are on board, the redundancy, the numbers that back each other up, and the number of uses that they're put to. So we have really reached an age where we're flying not only airplanes, but we're flying computerized airplanes.
I can see a family of airplanes that last for 60 or 70 years. They're in production for 40 years and fly for 30 years after that. This is an airplane that will make a real difference to the world.
With more than 1,800 computers on board, the 777 is a symbol of the technological progress which has dominated the 20th century. The total integration of the computer into the design and operation of commercial airplanes represents the start of a new era in commercial aviation.
When I think of this airplane, I think of the complexity of the machine. I was once flying at high altitudes and looking around and suddenly dawned on me there was no other living organism up there except us. And we were there because of the way we had encapsulated ourselves in this technology. So it's a tremendous experience that very few people in the history of the world, could even envision of being able to do this.
Few things have changed humanity with the speed and force of either the airplane or the computer. The continued integration of the two will forever change the world of commercial aviation. And one plane will lead the way into aviation's new century, the 777.